1-3, Measuring and Constructing Angles. This is Missy McCarthy, math teacher at Okemos High School. In the previous lesson, we talked a little bit about what a line was, and then we also defined what a line segment was. So here's just a little bit of review. We're asking the question, what is one of the major differences between a line and a line segment? Again, right now would be a good time for you to pause the video, think about what your response might be, jot a few things down in your notes, and then you can play the video again and compare it to what I came up with. You may come up with a slightly different answer, not to say that one answer is better than the other, but we're just thinking about the differences between a line and a line segment, and then we can compare our answers in class with others tomorrow. So my answer would be, a line continues forever in both directions. When I name a line, if I have 2 points on a line, points A and B, I will put my symbol for a line over the 2 letters and say that that's line AB. Whereas a line segment is only part of a line, and it definitely has endpoints. So a line segment does not continue in both directions, and line segment AB has a finite length. So that's how I would describe the difference between a line and a line segment. Now we can measure the distance between any 2 points if we think of a line as corresponding with the real number line that you dealt with a lot in algebra, where we can put points on the line and each one of those points corresponds to a real number. Then we can talk about finding what we call the distance between any 2 points. So if we had a line segment and we wanted to know how long that line segment was, we can measure its distance in the following way. Let's say we had our initial point A here at 1 and another point B here at 5. We can say the length of segment AB is 4 units. Now if they weren't so clear cut and you wanted to know, we can say the coordinate of point A is 1, the coordinate of point B, or is little a, the coordinate of point B is little b, and that sits here at 5. And what this says is you can find the distance between any 2 points by taking the absolute value of the difference of the coordinates. So if I wanted to find the distance between points A and B, I can take the absolute value of the difference of the coordinates. So the absolute value of 1 minus 5, which would be the absolute value of negative 4, and absolute value is the distance, so it is positive, so that would be 4. But we already knew that. So it doesn't matter whether you do A minus B or B minus A. If you do the absolute value, you will be finding the length of that segment AB or the distance between endpoints A and B. Now if I were to name this segment, I'm going to name the segment AB and make sure I put my dash over top of the A and B. But if I want to say that the length of AB is 4, I just write the letters AB, and with no dash over it, this means the length of segment AB, and I could say that the length of segment AB is equal to 4. So here we can find the length. Again, there's no dash over the BC and there's no dash over the AC. So we can find the length of segment BC by doing the absolute value of the coordinate that goes along with B is 1 minus the coordinate that goes along with C is 3. And the absolute value of 1 minus 3 is the absolute value of negative 2, and the absolute value of negative 2 is 2. So the length of segment BC is 2. If we wanted to find the length of segment AC, we would do the absolute value of the difference. We have negative 2 minus the coordinate that goes along with C is 3. That's the absolute value of negative 5, which is 5. So the length of segment AC is 5. Again, no dash. When we put a dash over it, that means segment AC. When we don't put a dash over it, it means the length of segment AC. This leads us into something called the segment addition postulate. Now, if you recall from the first lesson, a postulate is a statement that is accepted as true without proof. And they made actually an error in this diagram. They have an X here, and that actually should be an A. So the segment addition postulate says if B is between A and C. So we have point B here, and it is collinear. It lies on a line with points A and C. So that's what it means to be between. It's between A and C. Then AB, the length of segment AB, plus the length of segment BC equals the length of segment AC. So the length from A to B plus the length from B to C equals the total length from A to C. So again, it's a postulate. It's something that's almost common sense if you think about it, but it needs to be stated so that we can utilize it in a few different ways. So that's the segment addition postulate. We can use the segment addition postulate in this example. We have M, which is between N and O. Again, we just talked about what it means to be between. That means it has to be collinear. It's between those two letters and they're on a line together. So we can see here point M is between N and O. And we need to find the length of segment NO. So we can use the segment addition postulate here because we know that the length from N to M plus the length from M to O is equal to the length from N to O. So if we use a bit of substitution here, the length from N to M is 17 plus the length from M to O is 3x minus 5. And then the length from N to O is represented by 5x plus 2. So after we've done that substitution, now we can find out what x is and find the length from N to O. We're just going to do some algebra here by combining like terms and taking the variable to one side. The 17 minus 5 gives us 12 plus 3x equals 5x plus 2. If we were to subtract 3x from both sides, we get 12 equals 2x plus 2. If we were to subtract 2 from both sides, we get 10 equals 2x, and that leads us to x is equal to 5. But make sure that you answer the question. It says find the length of segment NO. We found the value of x. That is not the answer to the question. What we would have to do is substitute that back in. The length of NO is represented by the expression 5x plus 2. So if we take this value of 5 and we plug it back in, we get NO equals 5 times 5 plus 2. And the length of segment NO is 27. So we have finally answered the question. And that question involved the segment addition postulate. Another thing that we're going to talk a lot about is this concept of congruent segments. This word congruent is another word for segments of equal length, or we're going to use it with regards to angles and some other things. So if two things are congruent, that means that they have an equal measure. We indicate that two segments are congruent by putting little tick marks. If you put one tick mark on PQ and one tick mark on segment RS, you are saying that segment PQ has the same length as segment RS. We will talk a little bit about this symbol. This symbol means congruent, so we can say segment PQ, again we need our dash, is congruent to segment RS, which also means that they have the same length. So then we can say the length of PQ is equal to the length of segment RS. Now if we think about having one segment, oops, that would be a line, wouldn't it? If we think about having one segment, let's call this segment AB. And we wanted to find the midpoint of section AB. So that's going to be, again, a point that's collinear. Let's call this point M. Now, if it's going to be the midpoint, that means it's the point directly in the middle, which means that it divides that segment into two congruent parts. So I could put two tick marks on this and two tick marks on here, and that would be indicating that M is the midpoint, or the point directly in the middle, and that point M divides segment AB into two congruent segments. So the definition of a midpoint is a point that bisects or divides the segment into two congruent segments. Okay, so that's what a midpoint is. We also have this the concept of a segment bisector. Now, to bisect something usually means to divide it in half. So we have a point being the midpoint, but you can have any ray, segment, or line that divides, or that intersects, a segment, and now here's the word divides, at its midpoint, And if it intersects it at its midpoint, that means it divides it into two congruent parts. Okay, so if you had one segment here, let's say I had a ray MC. Ray MC would be a segment bisector because it intersects the segment at its midpoint and it divides it into two congruent parts. So let's try this. If we know that D is the midpoint of segment EF, and I would argue that that should have a mark over it, segment EF. So that ED is represented by 4x plus 6 and DF is represented by 7x minus 9. We need to find the length of ED, DF, and EF. So first I want to get a picture. I'm a very visual person. I want to see what they're talking about here. D is the midpoint. So that means D is the point directly in the middle, and it's in the middle of points E and F. And to show that it's directly in the middle, I can't just place it so that it looks like in the middle. I need some defining marks on my line to show that it is in the middle. So I'm going to put a single tick mark on each side showing that segment ED has the same length as segment DF. D is the midpoint. Now if that's the case, we also know that this 4x plus 6 is equivalent to our distance from E to D. And we know that from D to F, we've got a 7x minus 9. So this distance from D to F is 7x minus 9. Now the definition of a midpoint says that it breaks the segment into two congruent parts. So if that's the case, that means that the length of ED has to be equal to the length of DF. Using that, we could substitute in ED is 4x plus 6. DF is 7x minus 9. We can subtract 4x from both sides and get 6 equals 3x minus 9. Add 9 to both sides and we get 15 equals 3x, and that gives us that x is equal to 5. Again, we haven't answered the question because it didn't ask for the value of x. It asked for the values of ED, DF, and EF. So ED was represented by this 4x plus 6. So we do 4 times 5 plus 6, and we end up with 26. We don't even really need to do DF because we know ED and DF are the same. We can do it 7 times 5 minus 9. We get 35 minus 9, which is 26. And then that makes the length of EF 52.